So some more details on the collision theory. The four factors controlling the rate of a reaction are the concentration, the temperature, the particle size, and if a catalyst is present. So concentration, the more reactants you're going to have, the more collisions you're going to have, and that leads to a faster rate of reaction. You can also increase the concentration by increasing the pressure on the gas molecules. Remember, you can increase the pressure by increasing or reducing the volume, increasing the pressure. Temperature will also affect the rate of reaction. An increase in temperature will result in an increased rate of reaction because you're increasing the kinetic energy of the molecules. So kinetic energy is a factor of their velocity. If you increase the temperature, you increase the kinetic energy. A 10 degrees Celsius rise in temperature usually results in about a doubling of the rate of the reaction. Notice this curve, we call it a Maxwell-Boltzmann curve, and the blue line represents the reaction at a temperature lower than T2. Notice how as the temperature increases, the curve flattens, isn't that appropriate for us, and shifts a little bit to the right. Notice that the activation energy is in the same spot, so the activation energy is not changing, but now with the flattened curve, we have more reactants with enough energy to have an effective collision. So an increase in energy will always flatten the curve, shift the peak a little bit to the right, and increase the number of reactants that have enough energy for an effective collision. Particle size is also a factor for increasing the rate of a reaction. Only the surface that's available for the reaction can react. So if you break something up or make smaller pieces, you're more likely to have an effective reaction. So in the first diagram, you have some magnesium in a big piece surrounded by your acid and water. And on the right side, you have smaller pieces of magnesium. So higher surface area, more likely you'll have an effective reaction. Another way to look at it is looking at the magnesium again. The hydrogen's in red, and if you have a large piece, only the outside can be affected by the hydrogen. If you break it up, now you have all the magnesium is going to be available for the hydrogen to react with. So increase in surface area causes the rate of the reaction to increase. The last factor is the presence of a catalyst or catalysis. And notice the blue curve is when there is no catalyst. And so remember that curve is your activation energy. So without a catalyst, it's quite high. That's the energy needed for the reaction to be the minimum energy to be effective. Then if you add the catalyst, now we just have the lower bump. Let's just do it this way. Notice how much smaller the activation energy is. The addition of a catalyst reduces the activation energy. So effective collisions, just to look at this curve again, notice on the vertical we have the number of collisions with a certain kinetic energy. Notice that the catalyst is here, and that's a high activation energy. So remember that's with the large bump. We were looking at it in the other reaction. If you add a catalyst, that's when your activation energy changes. It goes lower, so notice the placement of this activation energy, and we have more molecules that have enough energy to have an effective collision.